You can say.
Hello, hello, hello.
All right. Our next speaker's name is Kwinten Pisman.
Teaching awesome Angular is this guy's mission.
If your RxJS has you needing therapy,
Kwinten is here with the perfect recipe.
Does this work? Can you hear me? Yeah. Surprise! I am back. Even though I'm not on the list again this year, but if someone cancels, then I always go like, "Put me in, coach. I want to go." So when I heard that someone was not able to come, Jürgen and Sam asked me to step in, and obviously I was very happy to do so. Even though it's quite unfortunate that someone again couldn't come, but I hope at least I can give you a good talk as well. So what I want to talk about today is one of the problems that I have faced, and also a lot of other people have faced, is that if you actually start using RxJS, it is very difficult. It has a very high learning curve, and you could almost say it's as difficult as climbing El Capitan, but I actually think that RxJS is even more difficult. Although I haven't climbed El Capitan, but I mean, it just doesn't seem that difficult, right? But once I started writing a lot of RxJS code, I started noticing these patterns that I was using over and over again. And that's some of the things I want to talk about today. So I want to show you some of the patterns that I came up with. But I also want to give you a little toolkit that can help you to determine how you can actually translate things you want to do into RxJS code. So I want to help you get that reactive mindset. But first of all, I want to thank Dominic, who's right there, because normally this is a duo talk. This is one I prepped together with him. So if you think the slide deck's not that good, it's 50% his fault, right? Okay, just remember that. A little bit about myself. My name is Kwinten. I'm a Google developer expert for Angular. I also do trainings with Strongbrew, and I recently started working for Stackblitz, which is an online editor. The top picture is how I actually look nowadays. The bottom picture is how you'll find me on social media. I just haven't figured out how to let go of losing my hair, so I'm keeping that picture for a little bit more. I want to talk about two projects that I've built together with Dominic, actually. One is Angular Checklist, which is a list of curated best practices that you can apply to every Angular application. So definitely check that out. And the second one is Angular Profiler DevTools, which is a Chrome extension that can actually visualize your componentry, and it can also visualize change detection inside of your application. That way you can know where you actually need to optimize your change detection. By the way, this only works in Ivy, and it actually is broken in Angular 9, so I need to fix that, but I'm at the conference right now, so that will be for next week. So, topic of today. We want to talk about patterns. But what is a pattern? So first, let's go to a common definition, and let's look at this one. In software engineering, a software design pattern is a general reusable solution to a commonly occurring problem within a given context in software design. So what does that mean? If you have some problems, and those problems always have kind of the same characteristics, and you solve them using the same tools and the same pieces of code, you've basically discovered a pattern. And that's what I want to tackle about. But in the context of this presentation, we're going to talk about three types of patterns, different levels. The first pattern is going to be an operator. In RxJS, we have these things called operators. And operators are so common use case things that we want to do with an observable that they're actually baked into the RxJS source code. So we could have an observable, and that observable is something we want to map over. So if we map over it, we get a new observable, and that's like a super common thing to do. So it's directly baked into the source code. And there's a lot of operators. On top of that, we have the thing that I want to talk about today, and that's a pattern. And a pattern is something that you would see in your own code base, and you would use it over and over again, but it might not be that common enough to actually put it into the source code. You don't know, maybe it is, and you can always suggest a new operator. But it's kind of something you use a lot. And if you combine a couple of these patterns together, you could get something that we call a recipe. And the last thing I show, if we have time enough, will actually be one of those recipes. Okay. Talking about code is cool, but seeing code work is even more fun. So we are going to do some patterns by example. And we are going to build a World of Jokes application because I have a really specific sense of humor. I really love Chuck Norris jokes, and especially Chuck Norris jokes in the context of programming. So we're going to build this application where we'll see jokes such as Chuck Norris can finish infinite loops in 4 seconds. I hope that's at least a little funny, because otherwise this is going to be a quite boring talk, I guess. But we get this from a designer, but what do we actually do with this? What does it actually need to do? So what we can do is we can go to our product manager, and then we are in luck. Our product manager is Michael Scott from The Office. I really love The Office. It's a great show. So when we go there and we ask him, like, what do we do with this design? And he tells us, well, we need a list of jokes that is cached, and it should be updated every 10 seconds. And if it fails, we want to retry, and we call every 5 seconds, and blah, 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 blah. And it just keeps on blurting out stuff. And when I leave the room, I'm kind of mad, and I want to punch a hole in the wall, because, I mean, what do I actually do with all of this information? This is super difficult. So one approach that we want to teach you is that we want to show you how you can actually use such a thing, which is kind of difficult, and kind of split it up. And to do that, we can use a divide and conquer. And we're going to apply this, but you can basically apply this to a lot of things. And in divide and conquer, you basically take a problem which seems unsolvable, and then you just split it up into multiple subproblems. And you keep doing this until these subproblems actually seem manageable. And once you have manageable problems, you fix those, you get sub-solutions, and then we're gonna reassemble those sub-solutions back together into a final solution. And that's also the approach that we're gonna take with regards to our requirements. But first, we have this guy, and this guy name is Dwight K. Schrute, and he's this really weird guy from The Office, but he's gonna give us some good tips today. So the first tip that he gives us is, if you have a difficult problem, use divide and conquer, split it up, solve the subproblems, and recombine to a final solution. Okay, with that in mind, if I take a look at this diagram, I can figure out some of these sub-requirements. So I could, for instance, say, okay, I need a list of jokes that is cached, and the cache is updated every 10 seconds, and so on and so forth. Okay, now that we have that, let's look at this first requirement. The list of jokes should be updated every 5 seconds. Now, how do I actually translate this into RxJS code? This is still something you would have gotten like years ago when people were not already using RxJS. So to do that, we're going to use something called pattern detection. And pattern detection is going to help you reason about your code. So we are always going to look for 3 things. We're going to look for the what, the when, and the how. Make sense? Probably not. Okay, let's go a little bit deeper. So the what is basically, what is our end result? What do we want to achieve when we implement this requirement? And we are going to think in that reactive mindset. So what's going to be really important is that our what is always going to be a stream. We are going to work towards a stream. When? That's actually an easy one. Usually a requirement starts with, if this happens, then I want you to do this. If this happens, that's going to be our trigger. That's going to be the trigger that sets off our observable chain. And again, trigger should always be an observable. We have a reactive mindset. If you do not have an observable, we are actually going to create one. And then we have the how, and the how is actually the pattern. How do we go from our trigger to the end result that we want? What are the operators that we need to apply to achieve that? So, Schroot's tip number 2, triggers and results should always be streams, because we want to have observables in our code base. So, the first requirement, the list of jokes should be updated every 5 seconds. So let's take a look at what is our what here. What do we want to achieve? Well, we know what should be an observable, and I want to have jokes on my screen, so I think I need a joke stream. That wasn't that difficult, right? When do I want to have jokes? Well, it literally says every 5 seconds, so I guess that's going to be my trigger. That's what I want to do. And how am I going to get there? Well, if I think about Angular, every time I want to get jokes from the backend, I basically perform a backend call and get my data. So I guess I want to perform a call every 5 seconds and then show it on the screen. That's not that difficult, right? Okay. We're going to apply this into an application, and our application has a really simple architecture. We have a jokes list component and a settings dialog component and a joke service where we're going to cache all of our jokes, and a settings service. So the first thing we're going to implement into our joke service, and I haven't told you this, but we're actually going to do some pair programming. I'm always quite nervous to do live coding, but someone once told me you should just tell the audience that you're going to do pair programming, and it's like everybody's responsible for my mistyping. So let's try and do that. So if I make a mistake, you have to help me. Okay, so we're going to go to our jokes service. And inside of my joke service, I have this HTTP call. And then I'm assigning that HTTP call to an observable. But what is there an error? Shit, where is it? No, okay. So we have our jokes, and we're fetching them only once. So what do I want to do again? Remember, my trigger was every 5 seconds. And our trigger should be an observable. But I do not have an observable. So what do? I create one. So I'm going to create an observable, and I'm going to use the timer operator to do that. And the timer operator is basically going to fire an event every 5 seconds, which is exactly what I want. And then in this case, it actually makes sense to use this flattening operator here, which is called exhaust map. And exhaust map is basically going to, I'm going to return a function, an observable here. And this is basically going to subscribe to the observable for us. So a flattening operator helps us to avoid having nested subscribes. So I'm quickly going to reassign this. This should look good. So we basically trigger every 5 seconds, and then after 5 seconds, we use exhaust map. We return an observable here. What does exhaust map do? Subscribes to the observable. What do we know when we subscribe to an observable? We execute it, so we do a backend call. And then I'm using share replay here because I basically want that result to be shared. So now, if we go to the application, we should hopefully be able to see some really cool jokes, and I'm going to read one. Chuck Norris finished World of... Oh, that was quite unfortunate. Did you see it refreshed before I could actually read it? So we have polling enabled, which is cool. This works. But we can actually improve on this. So this is the first pattern that we have. Oops. And let's first describe this pattern. And we've gave this some silly names. So this is called our repeater pattern. And it basically says if you have work that needs to be executed n times, where n is bigger than 1, what you can do is we can use this trigger, and then we can use a flattening operator, because we do not want to have nested subscribes. So we flatten this, and then we map it to the work that we want to do. So the work is the thing we actually want to repeat a couple of times. This is called the repeater pattern, which is something I use on an almost daily basis. So short step number 3, translate the written requirements into the what, when, and how. Because this is going to help you translate that requirement into RxJS code. So the second requirement, we only want to show the new data when the user actually requests it. So even though we have new data, we do not want to override it because people should be able to read the jokes, right? So what do we want to have? Quite easy. We want to have jokes stream on our screen, but only update it when we actually request it. So when do we want it? When the user requests it. So what are we going to do? How are we going to do that? Well, when the user requests it, I'm just going to get the latest value from my cache, right? That doesn't sound that difficult. Okay, so let's implement this. And this is something we're going to implement inside of our jokes list component. So inside of our jokes list component, we have our most recent jokes here, which is already set up. So what I'm going to do is I'm going to say that, well, now I kind of have a problem, right? Because I need to know when the user clicks a button. How does that work here? So I have this button here, and this button has a click handler, but it's currently not possible to create streams from click events in Angular templates until you watch Dominic's talk this afternoon. Just a small spoiler. But we're using this update next here. And what does this do? Well, update is basically a subject. And a subject is a special kind of observable in the sense that we can produce values for a subject. So what I'm going to do is I'm going to say this.update. And this is basically a stream that is firing every time the user clicks that button. So if I do this.update.pipe, and this is what I really like about RxJS, it's super declarative. What do I basically want to do? Whenever this fires, I want to get the latest value from my cache. Let me rephrase that just a little bit. I want to add data to this with the latest value from my cache. Did you see what I did there? No? Okay. What I did is with latest from, see? That's cool, right? And then I add my cache. So I can say with the latest value from my sort jokes. And then I obviously need to map this because the way with latest from works is it's going to give me an array where I have my trigger and my jokes. And in this case, I'm only interested in my jokes. So now I have this joke stream here, which is bound to my view, which has my initial jokes and now also my most recent jokes. We need these initial jokes because otherwise we wouldn't see any jokes on screen on the first render. So if I go to the application now, and we refresh this. Yep. Let's refresh this. So now I can read this joke. Chuck Norris knows the last digit of pi. Haha, super funny, yay. And actually, there was a backend call, but I can still see this. And now if I click this update, it's actually updated, which is pretty cool, right? So we already have this. But when I was prepping this talk with Dominic, and Dominic is kind of a pixel perfect guy, he hated the fact that this update button was here. Well, there might not be updates because I can click this even though there's no update. So that's something we fixed as well. So let's see how we can do that. But first, let's go to the pattern that we have. And this pattern is something we called the enricher. And the enricher is basically going to enrich data whenever a trigger fires. So whenever our trigger fires, we are going to combine it with the latest value from some other stream, and then we're going to enrich it. So in this case, we're just mapping to data, but we could also add, we can match or merge the trigger and the data inside of this map operator. So that's how we enrich it. But next requirement is if an update is available, the user should see a notification to update the list of jokes, but only if an update is available. So what do I want to have? I basically want to have a stream that is going to show me, that's going to tell me whether or not I need to show this notification bar. So I'm going to work to a show notification stream. And then when do I want to show it? Well, I want to show it whenever the cache fires data. That makes sense because there is new data. But when do I want to hide this? And this is where it becomes a little bit more complex because you want to hide it whenever, well, basically, if I think about it, if the user just clicked on the button, I'm pretty sure that there's no new data anymore. So I want to show it when the cache fires, but I also want to remove it when actually the user clicks on that button. So that's what we're going to do. And how are we going to do that? We're basically going to have two triggers, and we're going to merge them. So what does that mean? Go back to our code. And inside of our jokes list component, I'm going to create two streams. I'm going to have a show stream, which is going to equal something, and I'm going to have a hide stream, which is going to equal something. So my show stream is basically a stream that I want to emit true from because, well, I want to show my notifications bar. So I'm going to say if my source jokes fires, I'm going to take that trigger and I'm going to map it to a static true value. And if my hide stream, when do I want to do that? Well, basically whenever the user clicks that button, and I know it's this update button, I want to map this to a false value. So if I have a trigger that tells me when something is going to be false, and I have a trigger that tells me when something is going to be true, I can just say that my show notification stream is going to equal merging those two streams together. So I have one that says show, and I have one that says hi. And now the only thing I need to do, because I cannot type CSS code that fast, is I'm actually going to comment this in, and I'm going to comment this out. You did not see that, right? I did this super quickly. So if we go to our application, I can see that I have my jokes. It refreshes. I can now click this button. It goes away. Yay, that's a good thing. Let's wait till we have a new call, and I can, again, see that button. But we actually made a mistake, because if I refresh this, I can already see this update, even though there is no data. I think we made a mistake in our trigger, because I said whenever, oops, here we go, whenever my source jokes fires, I want to show it, but I probably do not want to do that for the first time, because the first time is when my first call is going to arrive, and then I'm just showing the data. But is the first data render an update? Probably not. So what we're going to do is we're actually going to change our trigger, and we're going to say that we're going to skip this first value. So we're only going to show our notification bar for the second time. So now you should see if a call arrives, which it does, that we have this bar. Wow, that's awesome. No? Yeah. Mm-hmm. Yay. Sorry, I got so excited about RxJS. OK, so that's requirement number 3. Let's take a look at our pattern, and this is called the group aggregator. I know these names are kind of silly, but whatever. So when we have a result, and that result should be an observable of Boolean, what we can just do is we can combine all of the values that are going to set it to true, put that into a stream, combine all of the values that are going to put it to false, combine that to a stream, and then we just merge it together to get a result stream. Okay? Next. And now it's where it's actually gonna become even more interesting, and you might actually be able to sprinkle some of the things you saw in the previous talk in this thing, but we're gonna keep it pretty simple. So we want our user to be able to manage settings. And these settings, well, settings is kind of state, so I'm gonna create this object, but what's really important is that we always put all of the state that we have inside of a stream. One of the biggest sources for bugs is when you would have a variable which is in a state you did not expect it to be. If we put our state inside of a stream, it can only be changed because of some trigger. And that trigger is, that's only one trigger, basically. So it becomes very deterministic when something is going to change. And that's going to actually help you with a lot of your bugs. So I want to have a setting stream. And that setting stream should encapsulate all of my settings data. When do I want to update it? Well, whenever the user changes one of the settings, so he has this dialog where he can change it, and that's where he can change this. And how am I going to do this? I'm going to keep the state inside of a stream, and then I'm going to update the state whenever this trigger fires. So let's take a look at how we're going to do that. And this is something we're going to do in the settings service. So inside of my settings service, I have this settings stream here. And in this case, I'm using a special kind of subject. I'm using a behavior subject. So we had a subject before to create a stream from our click events, but now we're going to use this to create a stream for state. And the specific thing about a behavior subject compared to a subject is that a behavior subject also has our initial state. So we can see that we have that initial state here. So what I'm going to do is I'm going to say that my settings, whenever my behavior subject fires, oops, let's do this dot settings equals this dot underscore settings. So whenever this one fires, I know I need to change my state. And changing a state is something you can do with the scan operator, which you also saw in the previous talk. And scan is basically going to allow us to, whenever this fires, and let me quickly type this because I'm really bad at typing and talking at the same time. So updates, whoops, that seems pretty okay-ish, I guess. Nobody says it's wrong, so I'm going to assume it is. So scan is basically going to allow us to calculate this state over time. So every time there's a new update, we're going to have an instance to the previous state, and then we can actually add our updates to it. So this is a very naive implementation of a state management tool, but it could be interesting for a beginning situation. So I'm going to subscribe to this to just be able to log it out. And now if we go to our application, I'm going to open my console. So you can see that we already have this initial state. And whenever I change something here, you can see that that stream also gets updated. And this is where it becomes really interesting. Because before, I said that triggers and results should be streamed. Now, I have a stream here. And this stream is actually going to be the trigger for my next requirement. So if your trigger and your result is a stream, you can easily compose these patterns back together. And that's where the real power in RxJS lies, composing patterns together. So this was requirement number 4. Shrewd step number 4, state should always be managed within a stream. Otherwise, you will not be able to use it as trigger for other patterns. So this is the state manager, and it's basically a very, very lightweight solution on how to do state management. I would not use this for full-blown applications, but for this demo application or something really small, it actually makes sense. And can I just ask the people from the audio to move on the screen so I can see the timer? Thank you. OK, so that's better. So shrewd step number 5. If we want to use the state management pattern, we can use it as a very minimalistic alternative to some full-blown solutions, such as Redux or NGRX. So last requirement I'm going to code, because I'm kind of running out of time. It should be possible to toggle the notifications and the polling. So what do I want to do? Well, I want to enable or disable my jokes and my show notifications. When do I want to do this? Whenever my settings change. So remember, we had a setting stream that we created in the previous pattern. So whenever these settings change, I'm going to react to that. And how am I going to do that? Well, I'm going to do that by conditionally stopping and starting the notifications of polling. And this is going to be our next pattern. So I'm going to go to my jokes list component. Jokes list component. And inside of my jokes list component, I now have this show notification. But I do not want to execute this all the time, because the user should be able to just delete the notification or hide the notifications all the time. So what I'm going to do is I'm going to say this.show notifications. Oh, not show notifications, settings service.settings. Remember, this was the result from our previous stream. And now I'm going to say, let me bump it up just a little bit more. And now I'm going to say, well, whenever these settings fire, I basically want to decide if the show notifications is true. I want to show the notifications, if there is an update at least. Otherwise, I want to hide them. So first thing I'm going to do is I'm going to map, and I'm going to take my settings, and I'm going to get the show notifications out. So I have these show notifications. And then what I could do is I could say that I'm going to switch map over this. And I'll explain in a bit what this actually does. So show notifications. And now I'm going to say if show notifications is true. What do I want to do if show notifications is true? I basically want to show the notifications if there are any. So I'm just going to take this. Oops, whoa, that was fast. I'm going to copy this, and I'm going to say if my show notifications is true, I'm going to return this stream. Else, if it's false, I'm going to return what? Well, I basically want to hide them all together. So I can basically say I'm going to return off false. I want to hide them. And then I'm going to take this, put it in front of here. And now I have a stream. And that stream is going to, every time the settings fires, it's going to get out the show notifications. And then it's going to switch map over that. Why switch map? Because switch map cancels the previous execution and starts a new one, which is what we want in this use case. And then we're checking if show notifications is true, then we return the previous pattern that we had. Remember, now we're already combining a couple of patterns together. And if it's not enabled, then we just want to say false so that the notifications is basically never shown. So if I save this and we go to the application, we should see if a network call fires. And that is now, that we have this update. But then if I go here and I basically toggle the notifications, you can see that this, oh, that was nice, no? Basically, everything kind of came together. Wow, that's magic, no? To me, it's still kind of magic. So, and this is really the power of RxJS. Because I changed something, the settings changed, and all of that thing, all of those events that we defined, like this is what needs to happen, happens. It's basically like a chain reaction. You don't define stuff anymore by, oh, I'm going to look up that value and then I'm going to hide or show them. You basically say, like we're doing in our code here, we're saying, oh, I know that showing my notifications depends on this stream, so I'm going to define it as a trigger for that stream. You're going to define stuff in terms of its dependencies. Hiding or showing the notification depends on the settings, so we define it based on that. That's really cool. So this pattern is what we call the work decider. So if you have work that needs to be stopped or started, or if you have, based on a certain decision, you want to do work A or work B, you can use this pattern. So based on a trigger, we can use a flattening operator. If it's actually restarting, you probably want to use switch map here as a flattening operator. And then you can check if the condition is true, we do this. Otherwise, we do that. That's cool. So short step number 6, use observables as the boundaries between services and components, because that is going to make our code composable. Because we expose that setting stream from our observable, it actually becomes composable. And then the last requirement, which I'm not going to type out, but I might be able to show you. So if the fetching fails, we want to retry fetching it. And if we are offline, we want to only retry if we're back online. Otherwise, we want to retry once every 5 seconds. And that's, again, pretty difficult now. So let's use the same divide and conquer approach. Remember, shoot step number 1. We're going to split this up. So we want to have, if the list fetching fails, we want to retry it. And actually, retrying is such a common scenario that there's an operator for that in RxJS. And we're going to use retry when for this. So we can basically, we don't need to think about the pattern here. And the next thing we want to do is if we're offline, we only want to retry if we're back online. And so let's just focus on that for now. So I want to retry this cache jokes. And when do I want to retry it? When an error occurs, call to the backend fails, and then we have a decision to make. Remember the previous pattern that we had? We were making a decision based on a notification value. Now we have a decision to make based on whether or not we're online. So we're already reusing this pattern. So how are we going to do that? Well, if we're online, we're going to retry, and if we're online, we're going to. If we're offline, we're only going to retry when we're back online. So I'm quickly going to cheat now and check out the next branch. So if I go to my jokes service, yes, joke service, you can see, and I'm not going to go into this too much, but we have a retry when here. And inside of my retry when, I have this error stream that fires whenever there's an error. And you can already, the only thing I want you to see here is that we're using this error decider again. We're using a decision based on a property. So if we're online, we're just going to retry immediately. And if we're offline, then we're only going to retry when we're back online. So we're basically, based on a condition, deciding which work we need to execute, a pattern that we're reusing, which is pretty cool. So now if I go to the application, and if I go offline, and I'm going to quit this. So we have one call that fails, which makes sense. Now we have no calls anymore. I need to talk for 5 seconds, otherwise you're not going to believe me. And then if I go back online, you see that we immediately have a call, which is pretty cool, I would say. Oops, wrong shortcut. OK, let's wrap this up. This is the pattern. Kind of already explained it, so I'm going to skip it. One thing you could also do is you can go from a pattern to an operator. If you have a pattern that you're reusing over and over again, you can transform that pattern into an operator for your code base. For instance, if you have like a debounce time in there with a specific time interval, putting that into a separate operator that you would use in your own application will make sure that it's always going to be the same for your entire application. OK, short step number 7, if we have a pattern that keeps emerging, put it into an operator. OK, key takeaways. I want you to remember divide and conquer. That's really, really important. Nothing is unfixable. Just think about it and solve problems. Patterns. You can use some of the patterns that I've shown you, but the most important key takeaway is pattern detection. Always think about what is actually going to trigger this action that needs to happen. Make that an observable. Where do I want to go towards to? Make that an observable, and then try to go from one to the other. That's the most important key takeaway, because that's going to give you that reactive mindset. And also think about custom operators. So think reactive, everything should be a stream, and that's it. Thank you very much.